alright มีมาเพิ่มนะ alright this is to YouTube and yeah what else no we did make the stream from this one chat ครับว่าแชทว่าณพัฒน์ครับพิมพ์ชื่อมาแล้วนะครับได้ครับไม่ทราบว่าใครนะเดี๋ยวwho is that พานาเมธาเขาชื่ออะไรนะครับเดี๋ยวnoภวินพานาเมธานะครับภวินพานาเมธาไม่ทราบว่าข้อมูลเป็นไงครับคราวที่แล้วคือเข้าอะไรยังไงใช่ไหมผมจะได้ติ๊กว่าปกตินะครับภวินใช่ป่ะเดี๋ยวผมจะได้ติ๊กเข้าแสดงว่าโอเคครับขอบคุณมากแสดงว่าภวินก็คือแสดงว่า604ก็คือเข้าครบทุกคนนะครับโอเคไหมโอเคมันผิดครับได้ครับเวลาเสียงอะไรไม่มีคุณแจ้งผมเลยนะครับจะได้พยายามจัดการแก้ไขผมไปนั่งดูคลิปย้อนหลังแล้วปรากฏว่ามีเสียงหายอยู่บางช่วงบางจังหวะนะครับพยายามไปให้หลายช่องทางมากที่สุดนะครับเพื่อว่าคุณจะได้เผื่อมันมีปัญหาอะไรนะครับคุณจะได้แบบมีทางเลือกทันทีนะเพราะว่ามันไลฟ์มันไม่ใช่อัดนะครับมันจะได้แก้ไขได้มันสดเลยครับเดี๋ยวผมลืมละStreamlab นี่ไปยังไงนะไม่ได้ใช้นานครับcontinue screen capture right right screen capture active event and YouTube yeah this one no number one, right, is SCI33205 M604. Today is 13.08.2021, right? Yes. Right. ไปแล้วนะครับno problem, got it. All right. Yes.พาวินก็คือเข้านะครับขอบคุณมากครับที่แจ้งครับwho else oh I have to let you get ผมไม่เข้าใจว่าทำไมต้องอนุญาตตลอดเลยนะน่าจะเข้ามาได้เลยเหมือนตอนแรกๆครับคราวที่แล้วมันมีพาสเวิร์ดอะไรด้วยเนาะokay we are 7 minutes late already I as well right. Not sure whether it's gone already or not. This one only in AD channel in YouTube. Okay. Please ไม่รู้อยู่ช่องไหนนะครับโอ้ยall rightที่อันนี้เปล่า yes. Okay, we go ahead with our story in the SCI33205, which is the physics number 4. Yeah, it's in another channel. My God. Anyway, don't worry. Yep. So I have to send you the link, right? Yeah. Yeah, we live today at the talk, right? The talk on conductor loop, and we are live at the solenoid version, which is the multiple version of where is that? Yeah, we reached the talk max expression, and here right in on figure here 6 more people. Okay, I hope that it's well prepared. Yeah, the current เดี๋ยวครับมันมี2 ช่องครับผมหาที่ Yes, this one.วีรพัฒน์ครับนี่ไว้วีรพัฒน์ก็ส่งวันนี้นะครับM604 this one and get into another account, the SWU account, right? New channel and this one as well, right? All right. I'm not sure which one works well. โอเคก็พิมพ์ชื่อเหมือนเดิมนะครับจะจริงๆผมไม่อยากเช็คนะแต่ว่ามันต้องส่งคะแนนให้คุณครูโคคุณครับมันเสียเวลาเสียอะไรหลายอย่างรบกวนเราเยอะแยะนะครับโอเคyeah I hope that everything is fine if nothing wrong 2 ช่องนะครับไม่รู้อันไหนนะครับมันมีจากSteam Lab ไปอีกอันนึงนะครับโอเคใครที่อยู่บน YouTube นะครับนั่นแหละครับทำมานะครับวันละไม่เกินอะไรไม่เกี่ยว alright นะครับข้อตกลงนะครับถ้าอยู่ข้างนอกซูมนะครับช่วยแคปเจอร์มาครับมันเสียเวลาผมจะต้องไปนั่งหาคุณนะครับalright yeah นี่ผมเซตก่อน20 นาทีนะครับเนี่ยเสียเวลาขนาดนี้ alright we are live here at the solenoid right and the solenoid is the extended version through to the single loop of conductor and the force that exists will 4 people more the force that will exist will be n times of that what we have in a single loop and of course the torque will be the result from the force so we would have also n times more force torque all right yeah we live here right the arrangement of the particular copper is called solenoid right in yeah solenoid is the helical winding of the wire okay that any material that you would like to build up the solenoid is possible okay right now we have 3 people in the YouTube I hope no one is going to have the lectures at the same time because I'm using now the internet from the university so it's very high the speed is very high if someone is holding his or her lecture that is gonna disturb us and I have to switch to the private internet okay arrangement of particular interest is the solenoid in if the windings are closely spaced this is the theoretical assumption okay is the is the ideal assumption, but it's quite close to reality. Okay, when the winding are closely spaced, and we usually use this assumption even we are in bachelor degree. All right, in the the total torque on solenoid can be assumed to be a simple version, which is the sum of the torques on each individual turn. So if you have n turns, for example, if you count here the number of turn that you may have in the coil or in the solenoid here, okay, you just multiply, okay, 1 2 3 4 5, okay, you just count มีใครอีกไหมเลยไม่มีนะครับyou just count the number of round or windings that happens in this solenoid. Okay, it's up to you. If you I will tell you later regarding the strength. Okay, if you take a look first here at the equation 54. Before that we have BR, right? BR side phi, BIA side phi, right? In the magnetic moment, okay, is denoted by mu, right? In is now it's the total torque is multiplied by a factor of capital N, right? Capital N is the number of turns, okay? In this one, for example, you just count 1 2 3 4 5. If you have 10 or 12 turns of the coil, so you would get the solenoid of 12 turns, and 12 will be substituted to this position, to this variable, the capital N. Okay, it's extended version, and usually we use a lot of turns, okay, inside the coils, because we as you can see here that the torque, the number of turns appear as the multiplicative factor. Okay, so simply speaking, the torque is directly proportional to the number of turns, or the number of turns is directly proportional to the torque. So if you have 2 turns, you get twice, okay, the strength of the torque comparing to the single turn in the coil. Okay, we arrive here at the first example, and we're gonna solve this. Let me check whether there is any problem in another channel or not. All right, let's take a look at this example. What is the shape, or which is important thing, the shape that we will consider here is circle. Okay, it's circular coil. All right, in circular coil should have the radius, right? In we have the average radius. Okay, maybe it's if you take a look at this figure, the radius of the circle in the solenoid might not be flat. Okay, it's tilted a little bit, but we assume that it's approximately as a flat circle. So sorry, the winding in the coil can be assumed to be a simple circle, and the average radius to that is gonna be a single value, okay, which is average radius to each individual turn in the coil in the solenoid. Okay, let's say the average radius is 0.05 meter, which is actually 5 centimeter. Okay, it's 5 centimeter. So yeah, it's it's very tiny, right? 5 centimeter. Yeah, it's considerable. It's not it's not very tiny. All right. Yeah. Circular coil and the number of turns, which is the new thing for us, is 30 turns, and it lies on a horizontal plane. It carries a current of 5 ampere. What is that? Okay, let me write down what is going to happen with this example or this problem. All right, so we have several rounds or several circles, okay, that represent the coins. This is the I don't know. Yeah, this is the output, and here is the input. Okay. Oh, sorry. You let the current get into this coil, right, and this solenoid, and we assume that you make the perfect circle to each round of the winding. So this is the radius. Okay, the radius R is 0.05 meter. Okay, and the current flow in this solenoid is 5 ampere, right? It's 5 ampere, and it's in the counterclockwise sense. Okay, it's I draw it in a wrong way. It should go like this. Okay. Oh no. Yeah, it's already correct. Okay, like this, and the number of turns is 30. So we have n equal 30 turns. All right. And when viewed from above, okay, it's the top view. คุณนะครับคุณเข้ามาครับ alright มันน่าจะมีพัดสดเนาะแล้วก็ให้คุณพิมพ์เข้ามากันเลยนะครับผมต้องมานั่งดูนะครับ alright the coil is in a uniform magnetic field. Okay, this the basic assumption to us. If it's not uniform, we would get trouble with that. But whether in we can get that situation, but we have to be involved with the นับเข้าซูมดูไม่ได้ดูนะครับเวลาสอนครับก็ต้องขออภัยด้วยครับมีคนไหนยังไม่ได้เข้าอีกครับดึงเข้าซูมเราจะคุณนะครับโอเคเข้ามาแล้วนะครับ alright the question to this problem is going to be as follow. Okay, the magnetic strength or magnetic flux density in this environment is, I don't know which direction, directed toward the right. Okay, from left to right. So B is gonna be in this direction, right? So yeah, that's vector B. Okay, and the strength of magnetic field magnetic flux density is 1.2 Tesla, like this. All right, and yeah, which way does the coil tend to? That's the second question. Anyway, we can also deliver or give the answer to the second question. It's not so difficult, but the first question requires more detail. Okay, we need to make the calculation. Which way does the coin tend to rotate in this scenario? So, of course, at this side, right, the coin is pointing, or the vector L is pointing like this, right? And B is gonna be like this, right? And this is the top view, okay? That's this position, okay, the right side of the coin. And of course, from L to B, right? L to B is gonna be it's gonna give us the downward direction, okay? L to B. So we get the pushing force in this position, right? And let's take a look at the left side of this one. It's counterclockwise, right? So L is gonna be here from the upper part to the lower part, right? And B is, this is vector L, right? And B is over here from L to B, right? L to B again. L to be like this, okay? This one, L to B, is gonna be like this, and we have to spin our four fingers, right? We have to rotate our four finger. You get the force in the direction out of pointing out of the plane, right? And the force is going to be lifting force, right? That's the force, and here is the force. Okay, so the coil is going to rotate like this, okay? Left up, okay? Left side is up, and the right side is down, right? Down. All right. Yeah, that's the rotation direction to the coil. Okay, the coil will rotate. The left side is going up, and the right side is going down. All right, and that's the typical where we could find the rotating direction to this to this solenoid. Okay, all right. We have the new word. The next one is find the magnetic moment. Okay, magnetic moment in this scenario is gonna be mu, right? That's the magnetic moment. But when we have n turns, this one, it means we have n. Okay, and yeah, what is mu n, or exactly the exact variable is mu 930. What is that, right? To this one, to the first sub question. And the second sub question is, what is the value of the torque here? Okay, so torque in, or the total torque, what is that? So we have to apply, right? I forget to mention, this is the most important formula. It's before that we have BR, right? Up to you, okay? You can say BR or BR, right? Or E bar, okay? Or RB, okay? Up to you. And there should be also the factor psi of phi or theta, right? Everywhere. And that's what we have for a single turn coil, okay? The coil that has only one turn. Once we deal with the solenoid, we would have an additional factor, which is the number of turns, right? So n is going to happen here, right? This is torque, right? It depends on which expression you are going to use to memorize this relation. You can say it's Bian, okay, Bian, or E-ban, okay, R-bin, it's up to you, okay? Any combination as you want, okay? But usually I prefer Bian, okay? So that is simple, okay? Only a single word in, yeah, let's start our calculation. Yeah. Oh my God, I use this format. All right, it's no problem. There. The first quantity we need to calculate is the total magnetic moment, right? The total magnetic moment. Let me see you in Zoom, right? Okay, all right, nothing wrong happened, right? And yeah, the first thing is the magnetic total magnetic moment, which is denoted by mu n, right, or mu 30, or up to you, okay, because n is 30 in this situation. For a general expression, we can say mu n, right? In yeah, we will go ahead with that. Yeah, mu n is this one, okay? Mu n is ian, okay? Ian. Regardless of the angle, so mu n is a n, right? In yeah, it's going to be of course we know that the current is provided there, which is 5 ampere, right? So we write down here 5 ampere, okay, for the current, and A is the area, right? The surface area, or that is surrounded by the coil in this one, in this winding, and we will use, because they say the perfect circle, right? We will use the expression of the circular area, right? It's A, and A should be the area of circle, right? Circle, right? Because they use this geometry, and times n, right? And A is the area of the circle is pi r square, right?ขึ้นอยู่กับคุณเลยนะผมไม่รู้ว่าคุณชอบเวอร์ชันไหนนะครับมันจะมีเวอร์ชันที่ไม่ลกๆไม่มีจอเล็กๆด้วยนะที่มันสะอาดก็สตรีมมาจากเขาเรียกว่าอะไรสตรีมแลบอะโอเคไหมครับจากหน้าจอ iPad เลยโอเคไหมครับบางทีถ้าหน้าจอ iPad อินเทอร์เน็ตมันติดขัดนะครับก็จะกระตุกคุณก็กลับมาดูที่ YouTube แล้วไม่รู้ที่ YouTube ถ้าเกิดเขามีวิชาอื่นสอนนะครับห้องข้างๆผมอะไรอย่างเงี้ยอาจารย์ท่านหนึ่งเขาสอนก็อาจจะดึงสัญญาณอินเทอร์เน็ตไปนะครับโอเคpi r square มันเป็นรสชาติใหม่นะสำหรับคุณที่เกิดในยุคโควิดนะครับโอเคไหมอาจจะเล่าให้รุ่นลูกรุ่นหลานฟังครับไม่เหมือนคนอื่นโอเค pi r square r in this case is 0.05 right so it's 0.05 meter, right? N square. That's the term for the A, right? N. N is the number of turns, okay, which is provided here 30. So we write down ข้อสอบก็คุณก็รู้ใช่ไหมว่าผมจะออกยังไงนะครับคงถ้าใครตกนี่ก็สุดๆแล้วนะครับเข้าใจนะครับว่าเรียนออนไลน์เครียดนะครับผมก็ไม่เกิดมาไม่ทันไม่เคยเจอนะครับก็ทำให้คุณเบาที่สุดละประมาณนี้นะครับไม่มีข้ออะไรโจทย์อะไรพลิกแพงสลับนะครับ30 turns right in yes you put it into the calculator and you will get the result like this where is that ขออนุญาตเปิดไฟล์นะครับในเครื่องคอมพิวเตอร์นะครับเพื่อหานะครับว่าalright it's chapter 2 right in yeah, magnetic electricity.โอ้ช้านิดนึงครับ ก็รันอะไร122 122 right there in yeah is so there. And after the calculation, you could get right oh no โอ้ไปซะเยอะเลยนะ oh all right yeah yeah when you put it into the typical expression you're gonna get the mu total, okay, or mu n, okay, it will be 1 approximately, right, because of the pi, right, 1.178, okay, and 1, okay, and that's the unit is of course the unit should be the result from each factor, right? First one is ampere, right? I is ampere, and A is the area, right? So it's meter square, right? In turns, you can write down also here turns, right? But simply speaking, ampere meter square, right? That's the first sub answer to the first to this question of magnetic moments, right? And the next one is the torque, okay, total torque, okay, because we are dealing with solenoid, okay, that has several turns. Total torque, TOQUE, right? And yeah, the torque in this sense is going to be tau, right? And yeah, Bian, right? BIAN and psi phi or psi theta, up to you, okay? All right, it doesn't matter what variable you are gonna use, okay? It's not the main interest to me. Yeah, yeah, we will add new thing, okay? You can also borrow, you can say that it's actually B and mu n, right, and psi theta, two new factors you have to insert it into this expression is the magnetic flux density and the angle phi, right? Yeah, the magnetic flux density is provided in it's equal to 1/2 Tesla, right? It's 1/2 Tesla, like this, okay, and you just take the value from mu n, right? It's not difficult. It's 1.1781, and the unit is ampere meter square, like that. And yeah, the new thing is psi, right? Psi of phi. All right, psi, and phi is the angle in this scenario between the normal vector, right, which is this one. This is the plane of the solenoid, right? And here is the normal vector, and the magnetic flux density is pointing in this way, right? So the angle between the magnetic flux density and the normal vector here is phi equal 90 degrees. So you put 90 degrees into this arguments, and of course it will give you number one. It has nothing meaningful. Sorry for that. And after you put these two numbers into calculators or by using any calculation method by hands and so on, you would get the result as 1.414, right? Approximately. And of course, torque, right? Torque is a kind of moment. It's the force time or multiplied by distance. So what you would have as the unit for the torque is going to be Newton, okay, unit of the force times the distance that you measured from the rotating point, which is meter, right? So that's it for the answer to this problem. Now we move to another problem, right here. Again circular while loop นะครับถ้าอยู่ห้องจริงผมเรียกคุณสุ่มคุณออกมาทำแล้วนะครับแต่ว่ามันไม่มีเนาะมันไม่มีห้องจริงครับก็ยอมรับไปตามสภาพแล้วกันครับ ผมก็ไม่สามารถบังคับทำอะไรให้คุณได้มากกว่านี้นะครับคุณอยากได้สัญญาณชัดผมก็หาให้นะครับอินเทอร์เน็ตอะไร iPad อะไรผมก็หาให้นะครับโควิดผมไม่สามารถทำให้นะครับมันเกินความสามารถผมแล้วนะครับเป็นแค่คนเดียวนะครับ a circular while loop of radius 1 meter. Okay, we arrive at the second example. Okay, so that you would be fluent. Okay, or you would be able to see how we apply that formula b and sine theta. A circular while loop. Okay, we have again the circular shape. Okay, because we are talking about the solenoid. Okay, multiple turns of coils. Circular while loop of radius 1 meter. Like this. All right. It's 1 meter. All right. And the normal to the is placed in magnetic field of 0.5 Tesla, like this. All right. Oh, I don't know which direction. Let's say it's in this direction. Okay. That's the, if it's wrong, we're gonna change it later. That's the magnetic field. The normal to the plane of the loop makes an 30 degree with the angle with the magnetic field. Okay, I'm wrong. Sorry for that. It's not the case. It's over there, right? Let's say. Oh no. The normal. Huh? What happened? Oh. Okay. What happened? All right. Yeah. The angle here is let's write down first the normal vector. Here is the normal vector to that. Yeah. And yeah, we have here right now the magnetic flux magnetic field vector, and I don't know which color we're gonna use. This one maybe. Here like this. Okay, that's the magnetic field direction vector, like this. All right, and the angle here is the angle here is 30 degree. All right, and that's the detail of this question. We will see what's going on. The current in the loop is somehow like that. อาจารย์ครับพอดีผมหลุดรบกวนดึงเข้าซูมผมมองไม่เห็นได้ครับไม่มีปัญหาครับ เกิดขึ้นได้เสมอครับเป็นสิ่งที่เราไม่สามารถควบคุมได้นะพวกอินเทอร์เน็ตเนี่ยอยู่ดีๆ True เขาจะไม่ปล่อยสัญญาณอย่างเงี้ยผมก็ไม่สามารถทำได้นะครับ AIS หรือว่า 3BB หรืออะไรก็ตามที่คุณใช้นะครับall right the current in the loop so actually the solenoid consists of a large number right of coils right so the current in the loop is I don't know which direction okay I equals 2 ampere right 2 ampere like this right yeah find the magnetic moment again okay this example is taken from a different book I think book number 2 and the previous example is taken from the book number 1 okay นะครับก็สิ่งที่เรียนไปมัน universal นะกว้างๆนะครับคุณไม่ต้องกังวลนะว่าผมไปหาอะไรแปลกๆมาโจทย์ทั่วไปนะครับง่ายๆนะครับหนังสือที่เขาใช้นะครับที่เป็นมาตรฐานทั่วๆไปนะครับถ้าคุณอยากได้แตกต่างยากกว่านี้ก็ทำได้นะครับติดต่อเป็นการส่วนตัวนะครับอันนี้สอนไปสำหรับคนที่เขาไม่เก่งด้วยนะครับเคยไหมเผื่อว่าธนานัทนะครับอยู่ที่ YouTube ช่องนั้นนะครับช่วยแคปเจอร์มาด้วยนะครับหรือว่าใครอยู่ที่อื่นนอกเหนือจากซูมนะครับแคปเจอร์หน้าจอแล้วก็ส่งมานะครับส่งมาในไลน์กลุ่มด้วยไม่งั้นผมต้องไปตามดูนะครับแล้วบางทีมันอาจจะไม่บันทึกแชทไว้ด้วยนะครับตรง YouTube นะครับผมบริการให้คุณดีที่สุดนะครับโอเคไหมthe current here is 2 ampere and magnetic moment which is the total version right mu n and what is that in magnitude of the torque what is torque n or torque total right we are dealing with solenoid so we have n turns okay of the coil yeah yeah it's not difficult right we would open the new empty page like this so that we could find again the mu n right mu n equal ผมเลือกโจทย์พื้นๆนะครับแค่ว่าเพราะว่าอาจจะมีคนที่เขาไม่เก่งนะครับด้วยอนุญาตแปะอีกรอบนะครับเท่านั้นได้ครับเพราะว่าถ้ามีคนเขาไม่เก่งนะผมเล่นโจทย์ยากเลยเดี๋ยวมันวัดอะไรไม่ค่อยได้นะครับโอเคไหมบางทีเขาก็ไม่เก่งไม่ชอบวิชาฟิสิกส์อะไรอย่างเงี้ยโอเคไหมขออภัยด้วยสำหรับคนที่ชอบอะไรแบบยากๆนะครับก็วิชาฟิสิกส์สมัยผมก็เป็นวิชาหนึ่งที่สนุกสนานดีนะครับหาโจทย์ยากๆทำนะครับคุณศึกษาเองนะครับหรือว่ามีติดปัญหาอะไรส่งโจทย์ส่งรูปมาเดี๋ยวผมจะช่วยคิดให้โอเคไหมครับเอานี้เอาพื้นนะครับสอนเนื้อหาพื้นแล้วก็โจทย์ธรรมดาครับเผื่อว่าบางทีคนเขาไม่เก่งก็อาจจะติดขัดไปนะครับเอานี้ธรรมดาครับ mu n I a n right n right so current is 2 ampere โอเคนะครับดูกีฬาโอลิมปิกนะครับจะแข่งนะครับเขาต้องฝึกซ้อมนะครับเช่นเดียวกันนะครับถ้าคุณอยากเก่งอยากเป็นฟิสิกส์โอลิมปิกคุณก็ต้องซ้อมนะครับไม่ใช่ทำโจทย์ดูเฉพาะผม2อันนี้นะครับคุณต้องไปหาโจทย์ทำเองนะครับA is the area right which is pi r square right again we use this circle shape so it's a of circle right the area of circle and the number r is what is that r is 1 meter right so it's not difficult it's number 1 only in n is the number of turns in this solenoid so they say circular y normal to the plane what is the number of loops to the loop makes มีตรงไหนไหมครับที่เขาบอกจำนวนขดลวดจำนวนเทิร์นมีไหมเอ่ย is there any place what is the solution to this one let's take a look to that there is no all right. The question has provided, the example has also provided a figure to that scenario. I forgot to mention. There is no information about a turn, so it means the number of turn is 1. All right, so yeah, it's no problem. The number of turn is 1, right? So 1 turn นะครับ1รอบนะครับ1ขดลวดนะครับ Okay, so you put it into the calculator. You're gonna get the answer, right? It's not difficult. It's not n actually. We have to remove n. Okay, it's simple. Mu. Okay, because we have only a single turn of the coil. So it's 6.2. Okay, it's only 2 pi, right? You can say 2 pi, but in this subject, please say it in decimal unit number. And in decimal numbers, 628, right? Again, the unit of mu magnetic moment is ampere square meter. And all right, that's the first quantity we can deliver. The second quantity is the torque, right? Torque is result from the single turn, right? So it's bian, right? Again, bian psi phi or psi theta, okay? ใช้ theta บ้างนะสำหรับคนที่ชอบ variable theta, okay? Bian RB, what is that? B is the magnetic flux density. They have provided here the 0.5 Tesla, right? So we're gonna leave 0.5 Tesla to that, and I and so on, okay, is gonna be the same as mu. Okay, you just put or replace it be mu, right, in sine theta. All right, here mu is 6.28, all right, which is ampere, and the unit is ampere meter square meter, all right, in sine theta. Theta right here is, okay, they have provided correct value, which is 30 degree, okay, the angle between the normal. Please be careful that if they say the angle between the magnetic field and the plane of the circle, and you have to deduce it, okay, or subtract it by 90, all right, 90 minus that value is going to be the angle between the magnetic field and the normal vector to that plane, right? Here they have provided the correct value, so we can simply include the angle 30 degree, okay, into this one. It's, of course, you know that it's 1 by 2 or 0.5, right? And here is again 0.5 is 1/4, okay, 1 by 4 of this value, which is the 1.5. Okay, 1.5 708, all right, and the torque unit is the product between the force and the distance, right? It's a kind of moment. So unit of force is Newton, unit of distance is meter, so it's Newton meter, and that's it for this shape of conductor right here. It's circle, all right. They have provided also the figure to that. And yeah, now we go to the next scenario. They are provided figure exactly on the same page, so we will not get confused at all. Magnetic moment, okay, to this one, and magnitude of the torque, all right, here มีใครสนใจทำนะอยู่ออนไลน์ก็สนใจทำได้นะyeah ใครสนใจทำไหมเอ่ยนะครับอนุญาตแปะนะครับผมไม่ได้ส่งลิงก์ไฟล์นี้ให้ไม่รู้คุณเข้ามาแก้ไข edit อะไรได้หรือเปล่าครับไฟล์ของเขาเรียกว่าอะไร Good Note อันนี้ครับใครสนใจทำนะครับ เข้ามาแทรกหน้าทำได้เลยนะไม่รู้ว่าเข้ามาในไฟล์นี้ได้หรือเปล่านะครับโอเคไหมมีใครสนใจไหมเอ่ยถ้าหากไม่มีก็ไม่ได้ดิอาจารย์พวกผู้ปกครองผมคุณพ่อแม่ผมจ่ายค่าเทอมอาจารย์ต้องสอนได้ครับโอเคไหมคือผมอยากเทสไม่ใช่ขี้เกียจนะอยากทดสอบว่าคุณรู้เรื่องหรือไม่นะครับจึงถามนะครับจึงอยากให้คุณทำนะครับ alright ค่ะปีที่แล้วก็โอ้โหเสียเวลานานนะครับให้คุณมานั่งคิดบนกระดานนะครับโอเคไหมก็คือไม่ได้ขี้เกียจนะแต่อยากให้คุณเป็นนะครับพาคุณฝึกพาคุณเรียนวิชาว่ายน้ำนะครับผมก็อยากเห็นคุณว่ายนะครับว่าคุณว่ายเป็นอย่างไรนะครับโอเคไหมคล้ายๆกันอย่างนั้น Okay, what you can see here is that there will be 3 strips, right? 3 portions, okay, of the 3 separated area of the coils. So there are 3 turns of coil in this scenario. So n is 3. Okay, please take a look at the figure carefully. You will see that the number of turns is 3. Alright เนี่ยนะครับมี3ช่องเนี่ยคุณเห็นไหมครับก็ n ก็เท่ากับ3ไปนะครับyeah again the direction between the normal vector of the plane and the magnetic field is 30 degree, okay, as same as before, right, as same as the previous figure. And now the shape of this solenoid, okay, it's not circle anymore, it's rectangle, right? So the area of rectangle is width and length, right? So yeah, it's not difficult. In this scenario, you can go ahead with the computation of the area in this solenoid, right? And what else? Nothing more, right? So we will apply the previous formula. Okay, mu n I a n ian, right? Ian. Okay, without theta phi. And of course, we know that a rectangle is the product between the width and the length. So the width is okay เขียนให้เต็มๆดีกว่าโอเคมาเดี๋ยวจะบางคนอาจจะตามไม่ทันครับwidth and length, right? This is the basic knowledge you got during your high school, your primary school, right? And yeah, width is the shorter side, right, which is 2 meter. So we're gonna write down here 2 meter, right? And the length, okay, the long side of the rectangle is 3 meter. 3 meter เสียงหายนะครับหรือว่าอะไรขัดข้องทางเทคโนโลยีทางเทคนิคนะครับเนื่องจากมันอยู่ไกลกันนะครับแจ้งผลทันทีคราวที่แล้วเสียงหายแล้วก็ไม่มีใครบอกผมนะครับ alright โอเคพี่คือธนารัตน์นะyeah it's not approximation, it's quite simple. It's 6 square meter for the area of the rectangle. So we go ahead with mu n, right? Mu n is gonna be what is the current in this scenario? The current will be the same, right? Which is 2 ampere. Which is 2 ampere. All right. And then the area, right, which is 6a, right, the variable a is 6 square meter. Okay, if we talk about the volume, it should be cubic meter, right? It's the meter with the power of 3, right? But here we are dealing with the area, so it's the meter with the power of 2 only in n, right? N is the number of turn. As we take a look before, we can see that there are 3 strips. It means the number of turn is 3. So we will write down here 3 turn, right? It's right here. It's not difficult. There is no need to make approximation at all. You can see 12, right? 12 and 3 is going to be 36, right? 30, I-A-N, right? It's 36, 36, and of course, IA, right? I has the unit of ampere, right? And A is the area which has the unit of square meter, right? It's going to be that, and that's the mu n. And torque n, okay, the total torque is the bian, right? Bian psi phi, right? All right, or simply speaking, it's equal to B n mu n, right? And psi phi, right? And we could insert the value into this expression, right? The additional thing is 0.5 Tesla. That's the magnetic flux density. And mu n, right, is 36 ampere square meter. And the psi phi, right? Psi phi is phi. The plane is tilted with the same angle as before, right? 30 degrees. So we would write down here 30 degree at this position. Okay, please pay attention to the angle. Okay, it's the angle between the normal vector and the magnetic field direction, right? So there is no approximation at all, right? 1/2 and 1/2. Okay, 1/4. 36 by 4 is going to be number 9, simply like that. And units for the torque is the Newton, right, times meter. Okay, it's a kind of moment. ผมจะพูดไปเรื่อยซ้ำๆครับจนคุณจับได้นะว่าทอร์กมันคือโมเมนต์นั่นแหละนะครับแรงคุริยธาตุนะครับ Alright, we arrive at the last sub question, which now is in the form of triangle. All right, it's shown in a different shape. Okay, you can apply this one to different or various surface or shape to this. All right, and yeah, all right, yeah, the triangle. Again, it is tilted with the angle 30 degree as before, right? 30 degrees. Okay, yeah. But okay, before it was rectangle, right? But this is the triangle, and as you know, triangle would have only half area of the rectangle. Okay, no problem. We will go ahead with that นะครับอย่าเพิ่งเบื่อนะมันก็คำนวณสูตรเดิมซ้ำๆไปนะครับใช้ซ้ำๆนะครับคุณก็จะคุ้นเคยแล้วก็จะจำสูตรไปได้อัตโนมัตินะครับขออภัยที่ดูน่าเบื่อนะครับมิวNO what is the number of turns in this solenoid? Okay, please count how many strips do we have in this figure. We have 2 strips, right? So the number of turn is going to be 2, right?